Imagine it's 4.55 p.m. on a Friday, you're wrapping up for the week, and you have this massive, complex project that just landed on your desk.
Oh, which is usually the universal signal for a ruined weekend.
Right.
Duh.
Usually that ruins your weekend. But instead, you type a quick set of instructions into your computer, close your laptop, and go home.
Yeah, you just log off.
Exactly. And while you're sleeping, or, while you're watching TV on Saturday and having brunch on Sunday, a digital worker labors for 48 uninterrupted hours.
Right. Actively checking its own work, navigating different software, and analyzing data.
Yep. And when you log back in on Monday morning, the finalized project is just waiting for you. Welcome to the deep dive. That scenario is actually no longer science fiction.
No, it's really not.
And today we're going to look at exactly how it became reality.
Well, it really is a profound shift in how we think about productivity.
Wow.
And the wildest part is that the foundational pieces for that specific scenario were entirely laid out in just 7 days.
Right. We are focusing exclusively on a highly consequential window of time. We're looking strictly at a series of updates published by OpenAI between April 19th and April 25th, 2026.
Yeah, if you want to understand where the entire global technology industry is heading, you really have to look at what was shipped during this single week.
Okay, let's unpack this. Why are we zeroing in on these specific 7 days?
Because this single week represents a permanent industry pivot. I mean, for the last few years, the prevailing paradigm for everyone has been the generative chatbot.
You know how it works? You type a prompt, it predicts the next words based on vast amounts of training data, and it generates text.
Right, it's completely reactive. But the developments published in late April 2026, they mark a definitive structural shift from that reactive text generation to autonomous digital labor.
We saw the arrival of a new frontier model, agentic operating environments, and the unprecedented computing infrastructure required to actually run it all.
Which is huge.
So we need to start with the core reasoning engine. Because before an AI can act autonomously while you're having brunch on a Sunday, its brain has to evolve.
Yeah, it has to move from simply predicting the next most likely word in a sentence to actually recursively verifying its own logic.
Exactly. Traditional models generate a response in a single forward pass. They just stream the words out.
Right. But the problem is, if there's a flaw in the logic at step 2 of a 10-step problem, the AI doesn't catch it. The entire output is ruined.
Yeah. Autonomous models, the kind capable of independent labor, have to be able to pause. They evaluate their intermediate steps, realize they made a mistake, and, self-correct before presenting a final output to you.
And that is exactly what dropped on April 23rd. According to the OpenAI blog and their API changelog, they launched GPT-5.5 along with a high compute pro variant.
And this thing features a massive 1 million token context window. For context, 1 million tokens is roughly the length of 10 full novels.
Right, meaning you can feed it an entire code base or an entire library of company policy documents in one go, but it's specifically optimized for what they call agentic coding and multi-step planning.
And we have the benchmarks to prove how good it is at that planning.
We do. GPT 5.5 secured a state-of-the-art 82.7% on Terminal Bench 2.0, which is an incredibly rigorous test for coding agents.
Wow.
But the critical metric here isn't just the high score, it's the efficiency. It achieved this 82.7% while utilizing significantly fewer tokens than its predecessor, GPT 5.4, to complete the exact same tasks.
Right, so explain why that token drop matters so much.
Because tokens are money. Every time an AI thinks, reads, or writes, it consumes compute power, which is billed by the token.
So when you're deploying AI at an enterprise scale, say having 10,000 digital workers running all weekend, token efficiency translates directly to massive improvements in cost efficiency.
Exactly. If a model can solve a problem in 10 steps instead of 50, it suddenly makes complex, multi-step digital labor economically viable for a business.
And it's not just software engineering seeing this leap. On April 22nd, the OpenAI Health Division released something called HealthBench Professional.
Yeah, and this isn't just a standard coding test. It's a physician-adjudicated open benchmark.
Right, meaning real doctors evaluated clinical AI across care consults, medical documentation, and research.
And the results they publish are staggering. OpenAI reported that the previous model, GPT 5.4, when operating inside their new specialized clinician workspace, scored a 99.6% safety and accuracy rating.
Wait, 99.6% on how many tests?
Across nearly 7,000 test conversations.
Wow. 99.6% on almost 7,000 clinical conversations.
Right. And by publishing this benchmark, OpenAI is setting a new verifiable baseline for medical AI. We're moving away from horizontal, general-purpose chat capabilities into highly specialized vertical execution.
Where accuracy is literally a matter of life and death. So to put this whole reasoning evolution into perspective, the leap to this new architecture is like moving from a really fast typist who needs constant supervision to a senior project manager who actually double-checks their own work before hitting send.
That is the perfect way to look at it. The model is no longer just typing, it's managing the workflow.
But having a smart project manager is totally useless if they don't have a computer to work on.
Right.
Now that the reasoning engine is upgraded, how do these models actually interact with the digital world? This brings us to the tools allowing the AI to essentially drive the computer.
Yeah, on April 22nd, OpenAI introduced Workspace Agents for ChatGPT. These are Codex-powered, persistent agents for teams that run entirely asynchronously in the background.
And they integrate deeply with enterprise apps you probably already use, like Slack and Salesforce.
This is a fundamental transition. It moves the platform from a reactive possession tool to a stateful, scheduled digital coworker. The key word there is stateful.
Because previously, when you closed a chat window, the AI basically developed amnesia. The context died.
Exactly. But with Workspace Agents, the context persists over time. You can schedule an agent to continuously monitor a live database, compile sales intelligence as it comes in, and execute organizational workflows.
All without a human having to constantly hit the enter key to prompt it.
Right. But to do that effectively across an entire company, the AI needs to be able to navigate legacy systems.
Because a lot of businesses do not run on shiny new software.
No, they don't. And that leads to a massive update published in the OpenAI Developer Cookbook on April 19th. They released documentation enabling these agents to visually perceive and control Debian-based sandbox desktops.
So we're talking about the AI using screenshots, moving a virtual mouse, and actually executing keystrokes.
Yeah, this solves a massive headache known as the API gap. An API is essentially a digital handshake that lets two pieces of software talk to each other cleanly in the background.
But not every piece of corporate software has a modern, clean back-end integration.
Right. There's software at major banks and logistics firms that is literally decades old. By giving the AI the ability to visually interpret a screen and physically click around, just like a human operator, it can operate legacy desktop software that has no modern API.
Okay, wait, hold on. Giving an AI the ability to literally click around a desktop and execute code sounds like a recipe for absolute disaster.
It does sound risky.
I mean, how does it not just accidentally highlight a database and hit the delete key? If it can click anything on the screen, the blast radius of a mistake seems massive.
It's a totally valid concern, and it's exactly why they aren't just letting it loose on your actual computer. They're utilizing what are called Daytona sandboxes.
Okay, what's that?
A sandbox is an ephemeral, highly isolated digital environment. The AI isn't clicking around on your live production server. It operates within a secure container where every single action is monitored. Furthermore, the architecture they documented includes strict permission checkpoints. If the agent attempts a highly sensitive action like formatting a drive or bulk deleting files, the workflow automatically pauses.
So basically raises its hand.
Exactly. It raises its hand and requires human cryptographic approval before that specific click is actually executed.
Okay, that makes a lot of sense. You contain the environment so it can't break out. But running these visual actions requires incredible speed.
It does.
And on April 22nd, the OpenAI engineering blog announced a major change to their plumbing. The Responses API transitioned from REST to WebSockets. This enables persistent bidirectional connections for these agentic workflows.
This is a massive change to the fundamental plumbing of the internet for AI. Think of a traditional REST API like a walkie-talkie.
You push a button, send a request, wait for the other person to process it, and then get a response back.
Right. Over and over. And that latency is totally fine if you're just generating a poem in a chat window. But imagine an agent making dozens of rapid tool calls, looking at a screen, clicking a mouse, reading the result, moving the mouse again.
That walkie-talkie delay would be crippling.
Exactly. WebSockets create a persistent open pipeline, like an open phone line where both sides can talk simultaneously. OpenAI noted this delivers up to a 40% lower end-to-end execution latency for rollouts exceeding 20 tool calls.
Which is what makes real-time autonomous loops practically viable.
Yep.
And it's not just code and text moving through those pipelines. On April 21st, OpenAI launched ChatGPT Images 2.0.
Which is powered by the GPT Image 2 architecture.
And this features an O-series thinking mode. The AI actually plans the visual composition logically before it starts rendering pixels.
which forces the retirement of DALL-E 2 and 3. And the reason this matters is the level of precision it achieves. Previous visual models use diffusion, which is essentially starting with static noise and refining it into a picture.
Great for art, but terrible for logic.
Exactly. Because this new model plans the layout logically first, it achieves production-grade multi-image consistency. More importantly, it finally solves a huge problem: highly accurate, multilingual text rendering.
Meaning it can reliably generate images containing perfectly spelled Japanese, Korean, or Hindi text.
Right. Which was a massive stumbling block for prior visual models that would just spit out illegible alien symbols when asked to write in non-English scripts.
So if we step back for a second, running millions of continuous real-time agents, letting them click around virtual desktops, keeping WebSocket pipelines open, and generating high-resolution multilingual images, that requires an unfathomable amount of hardware.
Oh,
But
absolutely.
where is the physical compute coming from to power all of this? According to filings and media tours covered by Data Center Dynamics in the AP around April 24th, we got to look at the Stargate Freebird facility.
Yeah.
This is a joint initiative by OpenAI, SoftBank, and Oracle, and they're building a massive data center in Milam County, Texas.
And the physical scale of this project is difficult to comprehend. The facility spans almost 550,000 square feet, and they are targeting completion by October 2026.
But square footage isn't the critical metric here, right? It's the power.
Exactly. This facility aims for a massive 1.2 gigawatts of total planned capacity. To put that in perspective, 1.2 gigawatts is enough to power a medium-sized city.
Wow.
This proves OpenAI's incredibly aggressive physical scaling. They're pouring gigawatts worth of concrete and securing power at a municipal scale to ensure they don't hit a compute bottleneck as these autonomous agents scale up.
Which makes sense.
If we connect this to the bigger picture, this massive capital expenditure down in Texas links directly back to the WebSockets API we just discussed.
Oh, right. Because to maintain millions of persistent, open, bidirectional WebSocket connections for real-time agentic loops, you can't rely on shared or fragmented cloud resources scattered across the globe.
No, you need dedicated gigawatt-scale infrastructure to guarantee that 40% latency reduction for enterprise clients.
And the hardware inside those Texas data centers is evolving just as fast. On April 22nd, NVIDIA confirmed that over 10,000 of its own employees are actively using the GPT-5.5 powered codex,
Yeah.
and they're running it on NVIDIA's massive GB200 NVL72 rack-scale systems.
This is a fascinating masterclass in unit economics. That NVIDIA system isn't just a single chip, it's an entire rack of servers acting as one massive GPU.
Right.
By running the new model on this specific next-generation hardware, it yields a 35 times lower cost per million tokens. Furthermore, it delivers 50 times higher token output per megawatt of power compared to previous generations.
Which is the missing link. This is what makes agentic AI economically viable at an enterprise scale. You simply can't deploy millions of agents if the compute cost of running them bankrupts the client.
Exactly.
But with Hoover Dam levels of intelligence coming online, the attack surface expands dramatically. How is OpenAI securing models that can actively write and execute code on a company's behalf?
Well, on April 22nd, the OpenAI security blog announced the release of something called the Privacy Filter Open Weight Model.
Right, this is a 1.5 billion parameter model published under a permissive Apache 2.0 license, and it's designed specifically to run locally on corporate networks to redact personally identifiable information, or PII.
This is a highly strategic move to solve a major enterprise roadblock. One of the biggest barriers to cloud AI adoption in sectors like global finance and healthcare is data sovereignty.
Because banks obviously don't want to send customer social security numbers to OpenAI's cloud.
Exactly. By releasing this filter to run at the edge, meaning on the client's own local servers, it automatically sanitizes and redacts the data before it ever leaves the building to hit the cloud.
This basically eliminates a massive compliance bottleneck, allowing strict regulation industries to adopt these frontier models safely.
Yeah, but protecting user data from the cloud is only one half of the security equation.
Right, the other half is protecting the AI model from malicious users.
Yes. When OpenAI published the GPT 5.5 system card, they explicitly rated the model's capabilities in biology as high.
And accompanying that, they launched a crowdsourced challenge targeting biosecurity. They're offering up to $25,000 for a single universal jailbreak, specifically in the Codex desktop environment.
Right.
I have to ask, is a $25,000 bounty really enough incentive to stop a catastrophic biological jailbreak? Or does this just highlight how incredibly difficult it is to secure models that are designed to be autonomous?
It highlights the sheer combinatorial complexity of securing an autonomous agent. It is incredibly difficult.
Mhm.
When an AI can reason through multiple steps over a weekend, traditional static content filters are utterly insufficient. A malicious actor could hide a harmful intent like synthesizing a dangerous pathogen inside a 10-step logic puzzle that looks harmless at step 1 and step 2.
So the $25,000 bounty is designed to attract elite external security researchers to find these holes.
Exactly. It's an open acknowledgement that internal red teaming alone simply cannot anticipate every possible edge case exploit in a system that thinks dynamically.
And this intense friction between capabilities and safety leads us to a highly serious development from this specific week. On April 24th and 25th, reports emerged from Tumbler Ridge, Canada.
Right.
According to reports from Midday and Yukon News, CEO Sam Altman issued a public apology regarding a mass shooting in the community. Altman acknowledged that the perpetrator's ChatGPT account had actually been flagged by automated systems for violent content 8 months prior to the incident.
But this flag was not reported to law enforcement.
Right.
The implications of this tragic event are already reshaping the regulatory landscape for artificial intelligence. This incident has triggered immediate lawsuits and a profound industry-wide reevaluation of algorithmic monitoring.
Because historically, tech platforms have operated under traditional safe harbor protections. They treat themselves as neutral digital infrastructure, like a phone company. They provide the line, but they aren't legally responsible for what people say on it.
Exactly. However, this event is rapidly shifting the legal debate toward establishing proactive duties of care. The massive question now being legislated is, when an algorithmic system flags intent, at what point does a technology company have a legal obligation to trigger human intervention and alert external authorities?
It's a massive shift. But solving these privacy, compliance, and legal hurdles clears the runway for the final piece of the puzzle: injecting this technology directly into the world's largest legacy corporations.
Right. Because up until now, OpenAI has been heavily tied to one specific tech giant.
Yes, Microsoft.
Yeah.
But on April 24th, CIO Dive reported that OpenAI announced its frontier models and managed agents will be available natively on Amazon Web Services, specifically AWS Bedrock.
This is a seismic shift in cloud dynamics. For years, OpenAI's deep, multi-billion-dollar partnership with Microsoft created a rigid cloud exclusivity paradigm.
Right, if you wanted the best OpenAI models natively, you use Microsoft Azure, period.
Exactly. By deploying natively on AWS Bedrock, OpenAI effectively breaks that paradigm. And why it matters is that it drastically expands OpenAI's total addressable market.
They can now seamlessly reach massive Fortune 500 enterprises that are structurally locked into Amazon's AWS ecosystems and were, historically hesitant or unable to migrate their massive data sets over to Azure.
Yeah, and to help those enterprises actually use the technology, they're bringing in human reinforcements.
On April 21st, global systems integrator Cognizant announced a partnership to embed Codex directly into corporate software engineering workflows.
What's fascinating here is the strategic brilliance of outsourcing the heavy lifting of enterprise integration. OpenAI is amazing at building the intelligence, but retrofitting a 50-year-old banking mainframe written in COBOL is a grueling, highly specialized task.
Oh, totally. By partnering with giant systems integrators like Cognizant, OpenAI bridges what we call the last mile of enterprise deployment.
Right. They're using human-in-the-loop consultants to modernize legacy mainframes safely. The consultants use the AI to decipher and refactor millions of lines of outdated code,
Ensuring that the autonomous agents play nicely with software built before the internet was even mainstream. So the staggering velocity of this single week cannot be overstated.
Oh.
Between April 19th and April 25th, 2026, we saw the release of the reasoning-heavy GPT-5.5 that double-checks its own work.
Yeah.
We saw the deployment of stateful agents capable of visually navigating your desktop computer. We saw the laying of gigawatts of concrete for data centers in Texas, the open sourcing of edge privacy filters, and the breaking of cloud exclusivity to reach AWS.
And it all forces us to reconsider the absolute fundamentals of digital labor. With agents now running asynchronously in the background via WebSockets and secure sandboxes, we are witnessing the decoupling of human time from execution time.
Right.
Think back to that scenario we opened with. You assign a complex data analysis and coding task on Friday afternoon. A digital worker labors for 48 uninterrupted hours over the weekend, utilizing recursive verification to check its own logic without needing a lunch break.
And when you log in on Monday, the finalized project is waiting.
Exactly. When human speed is no longer the bottleneck of productivity, how do we fundamentally redesign what a workweek even looks like?
That is the big question you and all of us are going to have to answer, and probably much sooner than we thought. Thank you for joining us for this deep dive into the sources and for taking the time to be informed with us. Until next time.